Hey guys, so today we're going to learn about a different method of solving quadratic equations. This method is called completing the square. It basically gets you the same answer that a quadratic formula would. Okay, oops. So this is an alternative method to quadratic formula. But you need to know both. So it's a longer process. It's not the best in terms of ease, but you do have to know both. Before you learn how to complete the square, you have to go over some basic concepts. One is that to solve an equation like the one up here, you have the option of factoring, which would be difference of squares, m plus 6 times m minus 6 equal to 0, which then you would set each part equal to 0. M plus 6 is 0, or m minus 6 is 0, so m equals negative 6, or m equals positive 6. These are the roots. But besides that, you have this alternative method, which is called square root method. If you have m squared minus 36 equal to 0, you could add 36, because there are only two terms and they're both perfect squares, you could take the square root on both sides. But the thing you have to remember is that the square root of 36 is not only 6, it's also negative 6, positive or negative 6. So that gives you the same two roots that you got that way, but using the square root method. We're going to be using square root method to solve by completing the square. That's why I'm going over it. The other concept you have to know is that of a perfect square trinomial. A perfect square trinomial is when you have a polynomial like the one in the example here, x squared minus 16x plus 64, and you want to factor it quickly, you'll notice that 16 is 8 plus 8 and 64 is 8 times 8. Now, the 16 is negative, so it's really negative 8 plus negative 8 and then negative 8 times negative 8. So this can be factored quickly as just x minus 8 squared, meaning x minus 8 times x minus 8 produces x squared minus 16x plus 64. Another example of this might be if I gave you x squared minus 9x plus 81. This can be factored into this should be 18. So it's 9 and times 9 plus 9 and 9 times 9. But notice this is a negative. So this would be x minus 9 squared. I'll do one more example, maybe like x squared plus 6x plus 9. So when you look at these numbers, 3 plus 3 is 6, 3 times 3 is 9. So this can be factored into x plus 3 squared. This time it's a plus because that was a plus. Okay, so we're going to be using these skills to now complete the square. I have a bunch of steps listed below, and you do have to memorize this whole process. So the first step is to transform the equation into the form of x squared plus bx equals c. What that means is that you are moving the c, the constant, over to the right side. It's the only time that you don't need a quadratic set equal to 0. So we're going to move the 32 by subtracting it over. Our first step is to get this to look like x squared minus 20x equals negative 32. Our second step is to take, well, actually, we're actually not going to do the second step today, but your coefficient of x squared must be 1, and if it's not, you have to divide. But we're not going to do that today. We're going to keep it easier, so you can skip step 2 for now. Step 3 is going to be take half of the middle term and square it. So we're going to take half of negative 20, which is the b term. I'll do that down here. I'm going to take half of negative 20, and I'm going to square it. So that's going to give me negative 10 squared, which is 100. And I'm going to add that number to both sides. So I'm going to add 100 to both sides. I now have, for my next line, I now have x squared minus 20x plus 100 equals, and then I add negative 32 plus 100, which is positive 68. Now when you do this, by doing this whole step here, you have now created a perfect square trinomial. On the left-hand side, whatever you get is always going to be a perfect square trinomial. So your next step, step 5, is to take that perfect square trinomial and rewrite it as a binomial squared. So we're going to rewrite x squared minus 20x plus 100 as x minus 10 squared equals 68. So because negative 10 times plus negative 10 is negative 20, and negative 10 times negative 10 is 100. So x minus 10 squared equals 68. Step 6 is we're now going to take the square root of each side by to isolate x. So we're going to take the square root of each side, square root on the left, square root on the right. And that's going to allow us to cancel the square root and the square root, giving us x minus 10 equals the square root of 68. But we have to remember the square root can be positive or negative. So that means I'm going to put plus or minus here. That's very important to remember. And now we're going to work on isolating x. That means we're going to simplify and write as two equations. So I'm going to add the 10 to isolate x. I get x equals, now I'm going to reverse the order of this. Instead of putting the square root first, I'm going to write 10 plus or minus the square root of 68. And now I can write as two equations and solve each equation. So x equals 10 plus the square root of 68, or x equals 10 minus the square root of 68. And this should look familiar. It looks kind of like the quadratic formula because this gives you the same answer as quadratic formula. And you pop it in your calculator and round to the nearest, in this case, the nearest tenth. 10 plus the square root of 68 is going to give us 18.2, rounded to the nearest tenth. And 10 minus the square root of 68 is going to give us 1.8, rounded to the nearest tenth. So those are our two roots, and you can express them as a set again. Okay. So this process does get better, and it does move faster along as you practice it more and more. So let's look at example 2. We'll do it again. It's set up where it's equal to 0. So you have to first move this c value over here. So we're going to subtract 23 on both sides. I now have k squared minus 12k equals negative 23. I'm going to take half of the b term and square it. So half of negative 12 is negative 6, squared is 36. This number gets added to both sides. So I go to both sides and I add 36. I now have k squared minus 12k plus 36 equals, and I'm going to add these, I'm going to end up with 13, positive 13. Now remember, whatever you get here will always be a perfect squared trinomial. So I rewrite this as some binomial squared equal to 13. I look at the numbers, I have 6 plus 6 is 12, and 6 times 6 is 36. And there's a minus here, so it would be k minus 6 squared. I now want to isolate x. To isolate x, I want to take the square root on both sides. So I'm going to take the square root here and take the square root here. This cancels. I now have k minus 6 equals the square root of 13, but don't forget, square root can be positive or negative. I'm now going to isolate k. I'm going to add 6 to both sides. But when I write this, I'm going to reverse the order. I'm going to write the 6 first. 6 plus or minus the square root of 13. And then I go to my calculator to solve each of these problems. K equals 6 plus the square root of 13, and k equals 6 minus the square root of 13. So 6 plus the square root of 13, rounded to the nearest hundredth this time, is 9.61. Or k, 9.61. An extra decimal point there. And then k equals 6 minus the square root of 13 is 2.394, so 2.39. And these are my two roots. Okay? So we are now going to move on to the last example, which is just slightly more complicated. Where this time you have to move the 26, and it's just like slightly more complicated. You now have, sorry guys, you now have a an additional number on the right side. So the only thing you need to do is just move this 26 over and combine it with the 8. So subtract 26. You now have x squared minus 10x equal to, and you'll have negative 18. Okay? And now you're back to where you were before. The same type of question. So you're going to take half of the b term, take half of negative 10, and square it. That's going to give you negative 5 squared is 25. That 25 gets added to both sides. So now we have x squared minus 10x plus 25 is equal to positive 7. Remember, this will always be a perfect square trinomial. So you rewrite it as a binomial squared. So 5 plus 5 is 10, and 5 times 5 is 25. So this would be x minus 5 squared. Again, minus because of this minus in the middle term. I now want to isolate x. So to isolate x, I'm going to take the square root on both sides. Remember, the square root and the squared cancel each other out. So we have x minus 5 equals, and remember the square root of 7 is positive or negative. I now isolate x. I am going to add 5 to both sides. And this is now going to become x equals 5 plus or minus the square root of 7. So when I do 2 problems, x equals 5 plus the square root of 7, or x equals 5 minus the square root of 7. So when I do 5 plus the square root of 7, I get to the nearest hundredth 7.6. It's 7.645, so I round it up to 7.65. That's one root, and then 5 minus the square root of 7 will be 2.35. Okay, so hopefully this helps. They're all pretty routine at this point. They all follow the same steps, and hopefully this can guide you. Okay, thanks.